Hello friends, today's topic is engineering thermodynamics. So in engineering thermodynamics, I'll be explaining a numerical problem from the chapter First Law of Thermodynamics. So let's begin. First I will read the question. Air is flowing in a 0.4 meter diameter pipe at a uniform velocity of 0.2 meter per second. The temperature and pressure are 300 Kelvin and 180 kilopascal respectively. Determine the mass flow rate of air. Take R is equal to 0.287 kilojoule per kg Kelvin. In this question, we have to find the value of mass flow rate of the air. That is, for every 1 second, how much kg of air is being passed through the pipe. Okay. For finding the value, some parameters are given in this question. First, the diameter of the pipe is 0.4 meter. Second, the velocity of the air is 0.2 meter per second. Third, the pressure of the air is 180 kilopascal. Fourth, the temperature of the air is 300 Kelvin. Fifth, the gas constant of the air is 0.287 kilojoule per kg Kelvin. So by using these 5 parameters, we are going to find the value of mass flow rate of air. Now we will move to the solving technique. First we will write down the formula of mass flow rate, and the formula is M is equal to A into capital V whole divided by small v. So here M is mass flow rate of air, A is area of the pipe, capital V is velocity of air, small v is volume of air. In this formula, area of pipe and volume of pipe are unknown. If we find the values of area of pipe and volume of pipe, we can easily find the value of mass flow rate of air. First, we will find the value of area of pipe, which is A. For finding the value of A, we will use the formula of area of circle because the shape of pipe is circular. So we know that the formula for area of circle is A is equal to pi by 4 into d square. So similarly, the formula for area of pipe will also be A is equal to pi by 4 into d square. So here A is area of pipe and d is diameter of pipe. So in this formula, we know the value of d. So we will substitute the value. We get A is equal to pi by 4 into 0.4 meter whole square. So in this RHS, 0.4 meter whole square is 0.16 meter square. So the next step will be A is equal to pi by 4 into 0.16 meter square. Now in this RHS, we will split the numerical terms and S units. So the next step will be A is equal to pi by 4 into 0.16 into meter square. So here pi by 4 into 0.16 is 0.125. So the next step will be A is equal to 0.125 meter square. So we have found the value of area of pipe. Now we will find the value of volume of pipe. We will use the formula PV is equal to RT, where P is pressure, V is volume, R is gas constant and T is temperature. So in this formula, we know the values of P, R and T. So we will substitute the values. We get 180 kilopascal into small v is equal to 0.287 kilojoule per kg Kelvin into 300 Kelvin. Now in this RHS, we will split the numerical terms and SI units. So the next step will be 180 kilopascal into small v is equal to 0.287 into 300 into kilojoule per kg Kelvin into Kelvin. So here 0.287 into 300 is 86.1 and kilojoule per kg Kelvin into Kelvin is kilojoule per kg because Kelvin and Kelvin gets cancelled. So the next step will be 180 kilopascal into small v is equal to 86.1 kilojoule per kg. In this LHS, kilopascal is 10 power 3 Newton per meter square and in this RHS, kilojoule is 10 power 3 Newton meter. So the next step will be 180 into 10 power 3 Newton per meter square into small v is equal to 86.1 into 10 power 3 Newton meter whole divided by kg. In this RHS, I am going to split the numerical terms and S units. So the next step will be 180 into 10 power 3 Newton per meter square into small v is equal to 86.1 into 10 power 3 Newton meter per kg. Now I will bring this 180 into 10 power 3 Newton per meter square to the denominator of RHS. We get small v is equal to 86.1 into 10 power 3 Newton meter per kg whole divided by 180 into 10 power 3 Newton per meter square. In this RHS, we will split the numerical terms and SI units. We get small v is equal to 86.1 into 10 power 3 whole divided by 180 into 10 power 3 into Newton meter per kg whole divided by Newton per meter square. So here 86.1 into 10 power 3 whole divided by 180 into 10 power 3 is 0.478, and this Newton meter per kg whole divided by Newton per meter square can be simplified by using a formula, and the formula is A by B whole divided by C by D is equal to A into D whole divided by B into C. So similarly, Newton meter per kg whole divided by Newton per meter square will be Newton meter into meter square whole divided by kg into Newton. So the next step will be small v is equal to 0.478 into Newton meter into meter square whole divided by kg into Newton. So in this RHS, Newton and Newton gets cancelled and meter into meter square will be meter cube. So therefore, the next step will be small v is equal to 0.478 meter cube per kg, which means the volume of air flows inside the pipe is 0.478 meter cube per kg. So we have found the values of area of pipe and volume of air. Now it's time to find the value of mass flow rate of air. Okay, so we know the formula m is equal to A into capital V whole divided by small v. So we will substitute the values. We get m is equal to 0.125 meter square into 0.2 meter per second whole divided by 0.478 meter cube per kg. Now in this RHS, we will split the numerical terms and SI units. We get m is equal to 0.125 into 0.2 whole divided by 0.478 into meter square into meter per second whole divided by meter cube per kg. So here 0.125 into 0.2 whole divided by 0.478 is 0.052, and meter square into meter per second is meter cube per second. So the next step will be m is equal to 0.052 into meters cube per second whole divided by meter cube per kg. So here meter cube per second whole divided by meter cube per kg can be simplified by using a formula A by B whole divided by C by D is equal to A into D whole divided by B into C. So similarly, meter cube per second whole divided by meter cube per kg will be meter cube into kg whole divided by second into meter cube. Okay, so the next step will be m is equal to 0.052 into meter cube into kg whole divided by second into meter cube. So here in this RHS, meter cube and meter cube gets cancelled. So the next step will be m is equal to 0.052 kg per second, means the mass flow rate of air is 0.052 kg per second. That is, for every 1 second 0.052 kg of air is flowing through the pipe. So friends, I hope you all would have understood. If any doubts are there, please do comment in comment box, and remember to like this video and don't forget to share this video to all your mechanical friends. Thank you friends.